Okay, problem 1 on the study guide. Find the equation of the directrix and the coordinates of the vertex and focus of the parabola given by the equation. I put graph paper here. I'll supply graph paper during the test. Sometimes, if we put it on graph paper, it makes it maybe a little easier to figure out where things are. First thing I want to do is create a standard form here. I want everything x to be on one side and everything y, and on the other side, since x is squared, I want the constant to go with y. So I'm going to say x squared plus 6x, leave a gap, equals negative 4y minus 5. The 4y and the 5 moved over, so they changed signs. Next, I want to complete the square. I take half of 6 is 3, 3 squared is 9, so plus 9 goes to both sides. And that gives me, on the left-hand side, x plus 3, the quantity squared, square root, sign in the middle term. On the right-hand side, I just add the like terms. I'm going to get plus 4 out of that. And I have a common factor. It doesn't even matter if it's a common factor. I don't want there to be a number in front of y, so whatever that is, I'm going to take it out. So negative 4 comes out, y minus 1 is left over. Keep in mind when you take out a negative, the signs change. So negative 4y changes to positive, positive 4 changes to negative. X is squared. I can see p is negative, and it means it's going to be turning downward, so I'm looking at a downward turning parabola right now. That helps me establish where things belong. The vertex of the parabola is going to be negative 3, positive 1. Remember to change the signs. This is the number that goes with x, change the sign. Number that goes with y, change the sign. So negative 3, comma 1 would be the vertex. That's one of the things they ask for. I'm going to go ahead and circle that. They want the coordinates of the directrix, the equation of the directrix and coordinates of the focus. So as far as the focus and directrix is concerned, I'm concerned with the value of 4p. 4p is equal to negative 4. 4p always equals this number. And then p is going to therefore equal negative 1. Okay, so negative 1 means go down 1 to get to the focus, go up 1 to get to the directrix. And keep in mind the directrix is a line. It's always going to be perpendicular to the axis of symmetry. Axis of symmetry goes through the vertex and focus. So the directrix is perpendicular to that and 1 away from the vertex. So go up 1 and make a horizontal line. There's my directrix. And just like that, I've got everything I need. So as far as answering the questions, coordinates of the focus, I look at this point, negative 3, comma 0. The directrix is a line. It's a horizontal line at a height of 2, so y equals 2. And that's all they ask for, and that's what I'll be asking for on the quiz. Number 2, find the equation of the parabola in standard form with vertex at negative 3, comma 2, and focus at negative 3, comma 0. Okay, once again, it's a downward turning parabola, so I'm expecting a standard form structure of x minus h, the quantity squared, equals 4p, parentheses, y minus k. So I established what standard form looks like, and that's what I need to know then is what h, k, and p equal. H is the x coordinate of the vertex, k is the y coordinate of the vertex. They gave me the vertex as negative 3, comma 2, so they told me h is negative 3, k is positive 2. And the focus, the distance from the vertex to the focus is p, so p is equal to negative 2. Directional distance there, be careful. We're always going from the vertex to the focus. We're going down 2 spaces, so negative 2. And once I know these 3 numbers, I just substitute those into the proper structure of standard form. Again, I know it's an x squared because it's going to turn downward. Downward turning is x squared. So the answer is going to be x plus 3, the quantity squared, equals negative 8, parentheses, y minus 2. So you pick the proper standard form and you find the value of the 3 numbers necessary to create the correct answer. Number 3, a satellite dish has the shape of a paraboloid. The signals that it receives are reflected to a receiver that's located at the focus of the paraboloid. The dish is 8 feet across at its opening and 1 foot deep at its center. determine the location of its focus. So it's paraboloid, so a cross section of the satellite dish is a parabola. It's 8 feet across, which means 4 feet to the right and 1 foot deep, 1 foot up. This is the center, so it must be 1 foot deep. So we're going to have the edges of the satellite dish 1 foot higher. -4, 1, therefore, is also a point. So if I was to draw a cross section of the dish, it looks kind of like this. I centered it to 0, 0. You should always do that. This point is 4, 1. This point is -4, 1. The fact that we have an upward turning parabola, vertex of 0, 0 gets me x squared equals 4py as its equation. And once I get to this point, because again 0, 0, just get x squared and y, the only thing I need to do is figure out what p is. That's what the focal point is. So I take one of the 2 points, I'm going to hit the positive one, 4, 1. X squared is going to be 4 squared, and 4py is going to be 4p times 1. So 16 equals 4p, so p is equal to 4. So the answer, where should the focus be? This is the focus 4 feet above the center. So 4 feet above center. And that's all the parabola problems. Moving on to ellipse problems. Find the standard form of the equation of the ellipse with center at 3, -1. Focal points of 3, 2, and 3, -4. Okay. With the ellipse, when it says find the standard form of the equation of the ellipse, it's x minus h the quantity squared over a squared plus y minus k the quantity squared over b squared is equal to 1. My goal here is to find h equals, k equals, a equals, and b equals. I might need to know what c is. Once I get that box filled in, I've got everything I need to write the answer. But again, start off with what standard form looks like, and then start filling in what you know. H and k are the coordinates of the center. So h is 3, k is -1. I know that c is equal to 1, 2, 3, because I can see the focal length. Okay. The other information they give me, it's a minor axis of length 6. Okay, if the focal points are up and down, that makes the major axis vertical. Focal points always lie on the major axis. The minor axis is length 6. That means 1, 2, 3 to the left, and 1, 2, 3 to the right would be vertices. And the fact that vertices lie there tells me that A must equal 3 also. Okay. And finally, if the major axis is vertical, that tells me that C squared is equal to B squared minus A squared. Remember, with ellipses, you either have b squared minus a squared or a squared minus b squared, depending on which one's bigger. Major axis vertical means b is bigger, so we're going to use that relationship between a, b, and c. Since I know both a and c, I can just substitute those numbers in. So c squared will be 3 squared equals b squared, I don't know yet, minus a squared will be 3 squared. 9 equals b squared minus 9, so therefore b squared has to equal 18. B squared equals 18. Okay. Wants to know h, k, a, and b, or b squared or a squared. I'm ready to write the answer. So h goes here, k goes here, a goes there, and b goes there. And then just substitute the numbers in. So x minus 3, the quantity squared, over a, which is 3, squared makes 9, plus y minus k is going to be y plus 1, the quantity squared, over b squared, which b squared is 18. It's already been squared, equals 1. And again, the equals 1 is a requirement. If you don't put it on there, you're not going to get full credit. If you left the equals 1 off of this, you get most credit. But again, don't forget that equals 1. Number 5, find the vertices and foci of the ellipse and sketch the graph. So, with ellipses, our first goal is to group the x's, group the y's, and move the constant to the other side. So, if we do that, I'm going to have 3x squared minus 12x plus 4y squared plus 24y equals -36. So That's priority 1. Do some grouping. Things of the same type go together. Priority 2, we want to have x squared and y squared. We don't want numbers in front of those, even if it doesn't divide evenly. So for the blue part here, I'm going to take a 3 out. That leaves me x squared minus 4x, leaving some space for completing the square. Then for this one, I'm going to take a 4 out. Again, even if it didn't divide by 4 evenly, we would do it anyway. So plus 4 parentheses y squared plus 6y, leave some space, equals negative 36. Then we complete the square, and half of 4 is 2, 2 squared is 4, half of 6 is 3, 3 squared is 9. What I truly added was 4 times 3, which is 12. And 4 times 9, which is 36. So you have to add the same amount to both sides. This one's necessary, this one's necessary. It's really 4 times 3, it's really 9 times 4. So 12 and 36 get added over there. That leaves me with 3 parentheses x minus 2 the quantity squared plus 4 parentheses y plus 3 the quantity squared is equal to 12. Negative and positive 36 cancel. 12 is left over. As far as factoring these, again, perfect square trinomial, square root sign, square root sign. Each time the binomial is squared. Last step is divide everything by 12. Again, standard form has that equals 1. We always want that equals 1. Now, 3 twelfths reduces to 1/4 and 4 twelfths reduces to 1/3. Always invert this fraction. So 12 over 3, even if it doesn't come out nice and pretty, 12 over 3 equals 4. 4 twelfths becomes 3. So this is 1/3 reciprocated is 3 over 1. This is 1/4 reciprocated is 4. So make sure that I've seen people just like drop that down and just call it x minus 2 over 1/4. But again, it's actually 12 over 3, which is 4, and 12 over 4, which is 3. So you're taking the bottom number divided by the top number to get these numbers. As far as everything I need, all the vertices and foci of the ellipse, I need the center first. So the center is going to be positive 2, negative 3. As with all these conic sections, we always change those signs from the standard form. So, oops, positive 2. Positive 2, negative 3. So, change the sign, negative becomes positive, positive becomes negative. So 1, 2, 1, 2, 3, that's the center. I can see that A is equal to 2. Let me write that down here. A is equal to 2. B is equal to the square root of 3, which is 1.73. And C, if I did A squared minus B squared is 1. C squared is 1, so C equals 1. So square root to get A, square root to get B, subtract and square root to get C. We're going to go 2 spaces left and right. To get vertices, we're going to go 1.73 spaces up and down to get vertices. And we're going to go 1 space right and left to get focal points. Connect the 4 vertices to get our ellipse. So there's the sketch. They want the vertices and the foci, so I'm going to list those. So the vertices are 0, negative 3, 4, negative 3, 2, negative probably 0.27, negative 1.27, and 1, 2, 3, 4.73. As far as focal points are concerned, we got 2 of them here, 1, negative 3, and 3, negative 3. Just a quick note about the vertices as far as getting the coordinates here. If I'm moving left and right, x is changing, so I take the center. If I add and subtract a, so 2 minus 2 is 0, 2 plus 2 is 4. Find the vertical vertices, this one and this one, and you're not sure about the specific numbers. The center plus 1.73, the center minus 1.73. So let's just say that you're unsure of what that's supposed to be. My center value is negative 3. If I add 1.73, I get the negative 1.27. if I subtract the 1.73, you get the negative 4.73. As I'm moving some direction up or down, notice that moving up and down, x stayed 2, y modified. As I move left and right, y stayed negative 3, x modified. So just keep that in mind as you're identifying points. If you have some decimals and you're a little unsure yourself, you can always verify with the calculator after you get your answers. But I'm looking for a graph, I'm looking for all the points for that. It didn't specifically ask for the center, so vertices and foci are what I'm looking for, but you have to know the center to get all those points. Number 6, find the equation of the ellipse in standard form. So once again, standard form of the ellipse equation is going to be x minus h the quantity squared over a squared plus y minus k the quantity squared over b squared is equal to 1. This time we have foci of -2, -2, and 4, -2. Okay, that immediately tells me that its major axis is horizontal. If the major axis is horizontal, that means the eccentricity equation, which is important here because they tell me about eccentricity. The eccentricity equation for this is going to be c over a, because it's horizontally positioned. I know for a fact if the focus is here and the focus is here, the center is halfway between those points. 1, 2, 3, 4, 5, 6 spaces across, so half of that's 3. 1, 2, 3 over gives me a center value of 2, -1, or sorry, 1, -2. Which tells me that, again, we need h equals, k equals, a equals, b equals, and maybe c equals. These are the 4 numbers I have to know to get the answer, but sometimes c is helpful to find those answers. The center is 1, -2, so h and k are known. I can see very clearly that the focal length here is 3. I have an eccentricity fact that c over a equals e. The eccentricity is 3/5. So 3/5 eccentricity equals c over a. So if 3 over 5 equals 3 over a must equal 5. You can cross multiply if you feel like it, but the fractions, tops are equal, bottoms have to be equal. And again, a major axis horizontal tells me that c squared is equal to a squared minus b squared. So whenever you're doing these equation ellipse, knowing the major axis is helpful. It gives you some information. If I know c squared equals a squared minus b squared, that means that c squared 9 equals a squared 25 minus b squared. If I move the b squared over there and the 9 over here, I'm going to get b squared is equal to 16. And notice again, I know a equals, I know what b squared equals. Be careful that when you're substituting the numbers back in, we're going to square the 5 to get 25. This is already squared, so 16. So all my numbers are known, my standard form structure is there. So x minus h squared over a 5 squared 25 plus y minus k is going to be y plus 2 squared. B is already squared, 16 equals 1. Number 7, Mars has a mean distance from the Sun of 142 million miles. The distance from Mars to the Sun is aphelion is 155 million miles. Find an equation for the orbit of Mars. So with orbits, we always want them to be horizontally positioned. We want c squared to equal a squared minus b squared. Aphelion distance minus mean distance is the focal length. So I know that c, in this case, is going to be 155 minus 142, which is 13. I also know that the mean distance is a every time. So these two numbers here help me to find b. So c squared equals a squared minus b squared. So if we move the b squared over here and the 13 squared over there, I'm going to get b squared equals 142 squared minus 13 squared. 142 squared minus 13 squared. So b squared is equal to 19,995. Well, I've got the calculator open. I'm going to type in 142 squared. That's a squared, which is 20,164. So we're going to center it at the origin, 0, 0. I've got a squared and b squared, so I'm going to have x squared over a squared plus y squared over b squared equals 1. A and b are in millions of miles. Identify that because it doesn't say 142 miles, it says 142 million miles, to make sure that if somebody's trying to figure out this orbit equation, they take the square root of 142 million, they have to make it in millions of miles. That makes for a much nicer looking equation. Number 8, that's the last of our ellipse problems. So now moving on to hyperbola problems. Find the center, vertices, foci, and slopes of asymptotes for the hyperbola y squared over 9 minus x squared over 16 equals 1. It's already in standard form. I can see y is squared, which tells me it's going to be an up-down hyperbola. I can see that my center is 0, 0 because x and y have no numbers attached to them. I also know that a is equal to 4 and b is equal to 3 because a is under x, b is under y, and they're being squared. I also know that c squared is going to be equal to a squared plus b squared, so c squared is equal to 25, therefore c must equal 5. So I found my center, I know what a, b, and c are, and a, b, and c are going to tell me everything I need to know. If I plot my center, and I go 3 spaces up and down, those are my focal points. I'm sorry, those are my vertices. Just spoke there. 3 spaces up and down. I'm going to go b spaces up and down. I'm going to go up and down because it's an up and down hyperbola, and I know that because y squared is positive. 3 spaces up and down are my vertices. And then 5 spaces up and down are going to be my focal points. And my asymptotes, slopes of asymptotes, are going to be plus or minus b over a. So as far as doing a little checklist, what we need to know, slopes of asymptotes, got it. The center, 0, 0, got it. Okay, as far as vertices are concerned, I just identify the coordinates at this point and this point, which are going to be 0, 3, and 0, negative 3. And as far as focal points are concerned, this point's coordinates are going to be 0, 5, and 0, negative 5. I didn't have to plot them to get all the information, but sometimes if we plot them, it's easier to identify the answers we're looking for. So by having them plotted, I can just look and say, you know, what coordinate is that, 0, 5, you know, that kind of thing. So that's what it asks for, center there, vertices there, foci there, equations of asymptotes, or slopes of asymptotes there. All it's asking for, that's all I'm going to do. Again, I'll supply graph paper during the test. You can use graph paper anytime you need to help you identify things. Okay, number 9, find center, vertices, foci, slope of asymptotes for this. So it's the same exact question, last one, except it doesn't start off in standard form. So priority 1 is make standard form. Just like we did in the ellipse problem, I'm going to group my x's together. 9x squared minus 54x. Group my y's together. Minus 25y squared minus 50y. And move the 169 to the other side, equals 169. Then I want x squared and y squared. I don't want numbers in front of those, so I'm going to take out the 9, even if it doesn't divide evenly. By the 54 it does though, but 9x squared divided by 9 is x squared. Negative 54x divided by 9 is negative 6x. Leave space. Be careful with hyperbolas that this number is actually negative 25 being deducted or taken out. So y squared is going to be plus, this minus 50 becomes plus 2y. Whatever sign that is changes because we're taking a negative out. Keep in mind what I have here should be equivalent to that. Negative 25 times y squared makes negative 25y squared. Negative 25 times positive 2y makes negative 50y. Okay, next. Once I got that, the 169 just is hanging out over there waiting to have stuff happen to it. Now I'm going to complete the square. So half of 6 is 3, 3 squared is 9. Half of 2 is 1, 1 squared is 1. In reality, I added 9 times 9, which is 81. and I multiply, or I've added 1 times negative 25, which is negative 25. So altogether, I've got 9 parentheses x minus 3 squared minus 25 parentheses y plus 1 squared equals 169 plus 81 is 250 minus 25 is 225. So just like that, I've got my structure that I'm looking for. X was something squared, y was something squared equals number. I want the number to equal to be 1. So divide by 225 to get the equals 1. As with the ellipse problem, I want to invert that and reduce if possible. 225 over 9 happens to equal 25. And 225 divided by 25 happens to equal 9. Again, if it didn't come out nice and pretty, 225 25ths. Leave it as a fraction, reduce the lowest terms. You just take whatever that fraction is and flip it, take that and flip it. So they want the center, the vertices, the foci, and the slopes of asymptotes. So I can see the center is going to be 3, negative 1. I can see that A is equal to 5, B is equal to 3, and C is going to be the square root of 34. Okay, and if I type in my calculator square root of 34, because I don't know right off the top of my head, it comes out to 5.83. My graph paper is not big enough to demonstrate it, but I got to go 5 spaces to the right, and then also 5.83 spaces to the right to get a vertex and a focus. I've got to go 5 spaces to the left and negative 5.83 spaces to the left to get a vertex and a focus. All right, so as far as getting coordinates, we'll deal with that in a second. The slopes of asymptotes, plus or minus, always b over a. So once I've got b and a listed, 3/5 are the slopes of the asymptotes. So that should be pretty simple every time. Okay, if we focus on the center, which is 3, negative 1, keep in mind to get vertices, I'm moving left and right. Left and right is affecting the x coordinate. So every one of these points is going to have common negative 1 for vertex, common negative 1 for focus. All I really have to figure out is what the x coordinate for each of these things is. Know for a fact that it's immediately going to be like that since we're moving left and right. If I was moving up and down, I'd be modifying the y coordinate, x would stay the same. So if I take 3 and add 5, I get 8. 3 minus 5 is negative 2 to get the focal points. 3 plus 5.83 is 8.83. 3 minus 5.83 is negative 2.83. A little prettier, but... Okay, so again, I didn't have to really graph anything to do that. For me, if I'm looking at graph paper, it gives me a better visual idea of what's going on, so I usually do that. But again, I can find this stuff just using basic calculations, knowing which direction I'm supposed to move. Moving left and right is modifying x. Moving up and down we modify y. In this case, we're moving left and right, so we're modifying x. Number 10. Given vertices negative 1, negative 4, and 7, negative 4, an eccentricity of 5/4, find the standard form of the equation hyperbola. So I can see that this hyperbola, vertices are left and right, which is the left-right hyperbola. Eccentricity of a left-right hyperbola is c over a. I can see very clearly, since the vertices are here and here, a distance of 1, 2, 3, 4, 5, 6, 7, 8 spaces apart tells me that half of that 4, 1, 2, 3, 4, is the position of the center. I can see it's left-right also, which tells me the standard form I'm looking for is x minus h, the quantity squared over a squared, minus y minus k, the quantity squared over b squared, equals 1. And I also need to know h, k, a, and b. So h equals something, k equals something, a equals something, b equals something. Obviously, the center is 1, 2, 3, negative 4. We can identify the coordinates of the center very easily just by counting. Okay, so we know h and k automatically. Since I know what a vertex and a center is, I can very clearly see that a is equal to 4. I know the eccentricity, so the eccentricity 5/4 equals C over A. We just found A to B for. And just like before, the fraction denominators are the same, so the fraction numerators have to be the same. So I know C is equal to 5. Again, these are the numbers I need to know. C is quite often useful in finding some of those numbers. Once I know 2 of the 3 of A, B, and C, the relationship between A, B, and C in a hyperbola is C squared equals A squared plus B squared. So 25 is equal to 16 plus B squared. Therefore, B squared is equal to 9. Again, if you know A or B or A squared or B squared, that's good information. Once I know HK, A, in this case B squared, I'm ready to write the answer. So x minus 3, the quantity squared, over 4 squared, which is 16, minus y plus 4, the quantity squared, over b squared, which is already squared, so over 9 equals 1. Okay. For the most part on this test, this quiz is going to be paying attention to detail. These x's and y's, you always subtract the h and k. Whatever these signs are, you always get opposite signs. That's quite often a mistake people make. They forget about changing signs. They'll have standard form and go -3, 4 instead of 3, -4. Or they'll have h and k and they'll say x plus 3 and x minus y minus 4. So be careful of that. I've seen people put x here and x here, so be careful to use x on one, y on the other. Wrong order because you don't think about which one's going left and right and stuff like that. You might get b squared equals 9, you write 81 there, or 8 equals 4 and you write 4 instead of 4 squared. So that kind of stuff, just paying attention to detail might help with getting full credit for the most part. And then again, preparing properly for this, doing all the practice you need to do to understand it, and you know, maybe really focus on techniques like completing the square that we've done a lot, but you need to really focus on detail when you're doing those. That type of stuff will help you out to have more success on this.